Here is the next example. We're going to solve this NPN transistor by assuming this is working in active mode of operation. So we know that IE equal to IC plus IB, beta value is 100. It's given by the manufacturer, but we should remember these three formulas all the time, and those three formulas are valid for both the NPN transistor and PNP transistor. Okay, all we know this NPN transistor because the arrow is going out of the emitter junction. Okay, so since I'm going to assume active mode of operation, I know that VBE, base to emitter voltage drop, is 0.7 volts. Okay, if we take the loop analysis, so I'm going to do the loop analysis. Loop 1, apply KVL. So if I apply KVL, minus 5 plus 10k IB plus 0.7 must be equal to 0. So IB must be 4.3 divided by 10k, which is 0.43 milliampere. Okay, once you know IB, IC must be IC equal to beta times IB, which is beta is 100, so we'll end up with 43 milliampere. And once you know IC, IE, do we need to find IE? Okay, we'll see. Do we need to find IE? Okay, so since I know IC, can we find VC? So 10 minus VC must be 2 kilo ohms times IC. So if you look at here, based on this, I mean 10 minus VC must be 2k times IC. Okay, so I already know IC, which is 43 milliampere. So 2k times 43 milli, you will end up with 86 volts. Okay, so VC equal to 10 minus 86, which is minus 76 volts. Okay, so if you look at VC is negative 76 volts. So VCE, and we know E is directly grounded, so VE must be 0. VCE equal to VC minus VE, which is minus 76 minus 0, so we'll end up with minus 76, which is less than 0.3 volts. So we know that in saturation mode, in active mode, I know the problem I'm solving is saturation mode, so saturation mode is coming all the time, so my apology. So in active mode, we know that VCE must be greater than 0.3 volts all the time. Then only we know that this transistor is working in active mode of operation. So in this case, our VCE is less than 0.3 volts. So the voltage here, so it must not be working in active mode of operation. So the transistor must be working in saturation mode. We have only active or saturation? No, we have cutoff mode. Then why don't we think about it's working in cutoff mode? If you think about cutoff mode, it's acting like an open switch, so IB, IC, IE must be equal to 0. If that's the case, if you look at VC, since there is no IC, we will end up with VC equal 10 volts, V equal to 0. So VC equal to 10 volts. So it must not be working in cutoff mode of operation. And we already checked it's not working in active mode of operation. So the remaining one is saturation mode of operation. In saturation mode of operation, the only thing we're going to take in saturation mode, take VCE equal to approximately 0.2 volts. So in saturation, take VCE is equal to 0.2 volts. That's how we're going to proceed solving the example. Okay, So let me take one more page here. Okay, I think I have enough room. Okay, I think I have enough room here. Now in saturation mode, so if you look at the transistor, we have 10 kilo ohm, 5 volts. So in saturation mode, both junctions are working in active mode of operation. So that's what we're going to take. Okay, so VE, this is 0, it's grounded, so this value must be 0.7 volts because the voltage drops. This is forward biased condition. The voltage drop will take that as 0.7. We'll take this voltage drop as 0.2 volts VC. Okay, so VCE equal to 0.2 volts. So you can see VC minus VE equal to 0.2 volts and VE equal to 0. So VC must be equal to 0.2 volts. Once we know VC, can we find IC? IC must be equal to 10 minus 0.2 divided by whatever that resistance value. I believe it's a 2 kilo ohm from the previous. So if you look at the main circuit, we have RC equal to 2 kilo ohms. I'm using that 2 kilo ohm. Okay, so if I use that formula, I will end up with IC equal to 4.9 milliampere. Okay, and VB equal to 0.7 volts. So IB must be 5 minus 0.7 over 10 kilo ohm, that is 0.43 milliampere. IB equal to 0.43 milliampere, and IE must be equal to IC plus IB, which is 4.9 milli plus 0.43 milli. So we'll end up with 5.33 milliampere. Okay, so once you know IE, once you find IC and IB, we can find the beta forced. So in saturation mode, beta equal to 100 will not work anymore. So we'll find the new beta value, which is IC over IB. So in saturation mode, since it's acting like a closed switch, we'll find the new beta value, which is IC over IB, which is 11.39. Okay, so beta equal to 100 will not work anymore. We'll find the new beta, which is 11.39. So in saturation mode, all you need to find IC, IB, IE, and beta forced. Okay, thank you.